In making a drawing, you will often find it necessary to represent rather complicated details on the inside of an object. On this hub, for example, the stepped shape of the hole is important, but it cannot be seen clearly from the outside. An ordinary front view would show these details by dotted lines. This is undesirable because you want to represent the hub as clearly and directly as possible. To overcome this difficulty, you can adopt a conventional practice which makes the drawing easier to read. Imagine that you can pass a cutting plane through the object and that this cutting plane cuts away half of the object so it can be removed, in your imagination, of course. Now, all the interior details can be seen clearly in a front view. Therefore, you can represent the cut object by the regular method of orthographic projection. The view is called a section or sectional view. Select those parts of the object through which the cutting plane theoretically passed and cross-hatch them with fine lines. Do not cross-hatch any parts beyond the cutting plane. Since the cut is only imaginary, show the top view in full as usual, but add a cutting plane line to indicate where the plane is supposed to pass, arrows to show the direction in which you look at the section, and reference letters to relate the cutting plane line to the sectional view. This particular section is called a full section because you imagine the cutting plane as passing all the way across the object. Remember that in making sectional views, as in other conventional practices, you adopt an arbitrary procedure in order to make the drawing clear. You can use the imaginary cutting plane in several ways. With some objects, you will need to show more interior details than one continuous cutting plane would reveal. That is, details on more than one plane inside the object. Here, for example, a section taken on one plane would not show both holes. Therefore, imagine a cutting plane which is offset so that it will reveal all the details you want to see. Now both the holes show clearly in the front view. In constructing the drawing, project the front view as usual, but do not indicate the offset because it is imaginary. Project the top view as usual and show by the cutting plane line how the cutting plane is offset. A view like this is also called a full section. Occasionally, it may be desirable to show details on both the outside and the inside of the object in the same view. With a symmetrical piece like this, it is possible to extend the cutting plane only halfway through the object to the center, and think of only 1/4 of the object as being cut away. This procedure creates a half section which does reveal both the outside and the inside of the object in one view. A half section is rather difficult to dimension, but it is acceptable if needed. Use a center line through the view showing the half section, but not an edge line. There is no edge because the cut is imaginary and the object is still round and full. Show the cutting plane as usual on the other view. Half sections are not found as often as full sections, but they may be useful. With certain objects, you may want to show some interior detail, like the hole in the threaded end of this bolt, without drawing a full or half section. Imagine the cutting plane as passing through the bolt lengthwise, and the part in front of the cutting plane as being broken out and removed to show the details inside. Project the view as usual and draw an irregular line to indicate the break. This type of section is called a broken out section. You can omit the cutting plane line because it is obvious where the cut was made. If you simply want to show the shape of some detail of construction, like a rib or the arm of a wheel, and don't want to make a full or broken out section, think of the cutting plane as passing perpendicular to the axis of the part to be sectioned, and the section thus made as revolving or turning up into the plane of the view. Then project the view and the part revolved, but omit the cutting plane line. When the sectional view can be contained in the drawing like this, it is called a revolved section. If the proportions of the object are different, however, more space may be needed to show the section itself or to add dimensions. In this case, imagine that you can revolve the section and then move it to one side. Construct the drawing and add a cutting plane line to show where the section was taken. Call this type of sectional view a removed section. Sometimes you need a sectional view from an auxiliary position. If you were drawing this block, for example, you could not use the front, side, or top views, full or in section, to show the step inside in its true shape, because this detail does not show in true shape in any of the principal planes of projection. When you have a case like this, imagine the cutting plane in an auxiliary position, and thus secure an auxiliary section which can be projected as any auxiliary view would be projected. While this particular view is an auxiliary sectional elevation, other objects may require right, left, front, or rear auxiliary sections, or broken out, revolved, or removed sections on an auxiliary plane. The construction of sectional views is a convention which makes the drawing clear. Other conventional practices have the same objective, to make the drawing easier to read. For example, in constructing sectional views, do not cross-hatch small parts which have no interior detail, but show them full, as if the cutting plane did not pass through them. Apply this rule to shafts, to bolts and nuts, rods and rivets, to keys, and so forth. Following another conventional practice, do not show invisible lines on a sectional view because they would confuse the drawing. Omit them unless they're absolutely necessary to describe the shape of the object. This drawing illustrates other conventional practices in cross-hatching. Notice that adjacent pieces should be cross-hatched in opposite directions, as you see here. Notice that cross-hatching should be the same here and here, because each side of the gear is part of the same piece. Notice also the cross-hatching here, and then observe that if a broken out section were made here, the cross-hatching would be the same in this view, because these flanges are parts of the same pieces shown in the front view. In other words, cross-hatching for the same piece should be the same, whether in one view or in different views. Besides those you've seen, there are other conventional practices, and these apply to both sectional and full views. For example, there are times when you give a misleading impression if you follow the rules of projection strictly. Take this hand wheel. It is symmetrical. Yet true projection of the side view would make you think that the arms were unevenly spaced. Therefore, construct the side view as if the arm were revolved or aligned. You know that this conventional representation of the side view is not a true picture, but it gives a truer impression of the symmetrical shape of the object. Apply the same rule to sectional views for this kind of object. Think of the cutting plane passing through the object, as usual, to make a section. And imagine part of the wheel as removed. But when you make the drawing, violate the strict rules of projection and show the arm as if it were revolved or aligned. Do not crosshatch either arm on the sectional view, though other parts should be crosshatched as usual. You should follow the same convention in representing the holes in a drilled flange, because symmetry is also a factor here. You will naturally make a sectional view. But even so, true projection would show most of the holes by dotted lines in positions which give a misleading effect. It is better practice to show the holes at their true radial distance as if they were swung around into the plane of the section before they were projected. Apply a similar convention when you want to represent ribs or webs in sectional view. In making the section, you discover that a true sectional view would show no distinction between the ribs and the rest of the piece, giving the impression that the ribs are thick. You cannot avoid this difficulty by passing the cutting plane through the object at another angle, because the ribs would then appear foreshortened, and this is not a true picture either. The conventional solution is to imagine the cutting plane passing through the ribs as it did in the first place and cutting away the front part of the object. But then on the drawing, omit the cross-hatching of the ribs as if the cutting plane had passed in front of them. This view, together with the top view, gives a good impression of the shape and thickness of the ribs. In studying these and other conventions, remember the principles you have learned so far. An imaginary cutting away of the object reveals interior details and makes the drawing easier to read. Only those parts are cross-hatched through which the cutting plane passes. Since the cut is imaginary, no edge is indicated between the sectional and exterior portions of the view, because the object is still round and full. Besides full and half sections, other sectional views can be made. Broken out sections, revolved sections, removed sections, and auxiliary sections. And then, in adopting conventional practices, remember the words of the late Professor French, who said, "One statement may be made with the force of a rule. If anything in clearness can be gained by violating a principle of projection, violate it."